Alright, y'all, now that we are masters of the rational expression and equation, we're going to graph it. Let's see what these things look like on a graph. There are a lot of little pieces that we need to put together for these graphs. So first I'm just going to talk about what each of those pieces comes out to be, and then we'll get into some examples. So we're familiar with the rational function. It is a set of polynomials as a fraction. In these graphs, a lot of times we're going to have vertical asymptotes and we're going to have horizontal asymptotes. We're not always going to have both, but when we have a vertical asymptote, that happens when the denominator is set equal to 0. So what that means is we're going to either be given some sort of trinomial or polynomial, or maybe some factors, and we need to set that denominator equal to 0. For the horizontal asymptote, that is based on the degree of the numerator along with the degree of the denominator. If the degree of the numerator, the highest exponent, is smaller than the degree of the denominator, you'll have a horizontal asymptote at y equal to 0. It's horizontal, so it's y equals. If those degrees are equal, in order to find our horizontal asymptote, we're going to take the leading coefficient of the numerator over the leading coefficient of the denominator, and then simplify the fraction if it can be simplified. If the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote at all. When it comes to actually graphing these, once we have all of our asymptotes, if you have an odd degree at a specific asymptote, then your arrows are going to be away from each other. So the options are that they're right next to each other or that they're away from each other. If it's an odd degree, they're away from each other. If it's an even degree, they're going to be right next to each other. Also, if you have a positive leading coefficient, you're going to start on the right side of the graph above your horizontal asymptote. If you have a negative leading coefficient, you'll start below that horizontal asymptote, again on the right side of your graph. To find an x-intercept, we're going to set the numerator equal to 0. So this is similar to the vertical asymptote, but this time we're dealing with the numerator instead of the denominator. Once we have set it equal to 0 and we've got the factors, we're going to see if we either go through that x-intercept, maybe we bounce off of it, maybe we do a little bit of a squiggle, just depending on the degree of that factor. Finally, the y-intercept. We're basically just going to let x equal to 0, let x be equal to 0 everywhere in our function. So anywhere we see an x, we're going to evaluate it at 0. I know that's a lot of information, so let's look at an example. We've got the function y equals 4 over x minus 3. The first thing we're going to find before we start to graph anything is the vertical asymptote. So if you remember from those rules in the previous part of the video, the vertical asymptote is where our denominator is equal to 0. So for the vertical asymptote, I'm going to set x minus 3 equal to 0. Then I'm going to solve for x, because our vertical asymptote should be x equal to a number because it's vertical, which is exactly what we're going to get here when we add 3 to both sides. We have that asymptote at x equal to 3. I'm going to go ahead and put that on my graph. A lot of these are just sketches, so I'm just going to kind of guess where 3 might be. It's not going to be perfect. The idea is just to figure out what the graph is kind of doing in a specific region. For the horizontal asymptote, we look at the degree of the numerator and the degree of the denominator. There are no x's in our numerator, so the degree there is 0. N is 0. There's only one x. It's not squared, it's not to the third, it's just to the power of 1. So the degree of the denominator is 1. Since 0 is less than 1, then we have a horizontal asymptote at y equal to 0. For our x-intercept, that's where we would set the numerator equal to 0 and try to solve. If we can't solve it, then there is no x-intercept. So here our numerator is 4. I'm going to set that equal to 0. Is that a true statement? No, 4 is not equal to 0. So here there are no x-intercepts. So I'm just going to put none. This graph is never going to cross that x-axis. Finally, for the y-intercept, here's where we're going to be plugging in 0 everywhere we see x. So the only x we have is in the denominator here. So we've got 4 over 0 minus 3. 0 minus 3 is negative 3. So we have a y-intercept at 0, -4/3. This is a point, so we're including it with that 0 because we used the x value of 0 to find that -4/3. So we can plot our horizontal asymptote at y equal to 0. We don't have any x-intercepts, nothing to plot there. We have a y-intercept at 0, -4/3, so we're just going to go down a little bit. Again, these aren't going to be perfect. It's just a rough sketch of what's kind of going on here. Now when it comes to the arrows and what is going on, like when we're going down, when we're going up, that sort of stuff, I'm going to base it on my horizontal asymptote. If my numerator is positive, if my entire fraction is positive, then I'm going to start above the horizontal asymptote. If my fraction were negative, I'd start below the horizontal asymptote. So I'm going to start with a line that's hugging that asymptote. Remember, an asymptote is a line we get really close to but never actually touch. So we're hugging that asymptote, and since there's nothing happening, there are no points we need to touch, the next thing that we see is another asymptote. We're going to hug that asymptote. We're not going to cross that vertical asymptote. We're just going to get up to it and hug it, getting really, really close to it. Then, to see what's happening on the other side of that vertical asymptote, which was at 3, I'm going to look at the degree of that factor that gave me the 3. So here, that factor was x minus 3. It has a degree of 1, which is odd. If we have an odd degree, I'm going to put an O above that line for odd. Then remember, our arrows need to be away from each other, not next to each other. So since they need to be away from each other, I'm going to start down below. If it was even, I would start right up here next to it. But since it's odd, I'm starting down at the bottom this time. And now I actually have to go through this specific point. So I'm going to hug my asymptote. Then I'm going to get close to that point, go through it. Then the next thing that happens is another asymptote. There are no other points I have to go through. So I'm just going to keep hugging that asymptote, and that's going to go on forever.